Alright, looks like it's a good time to get started. And right now we're going to talk about algebra of functions, and we're going to talk about something special with them, and that is the composition of functions. Now, when we talk about the composition of functions, we use this very specific notation. That is, if we're composing something, we'll usually say like f composed with g, or f of g of x, and we use this sort of raised circle. And when we'd say this, we'd say it's f of g of x. Well, but here's the thing. Remember when we said that with a regular function, you could think of this as sort of a numbers in and numbers out? Well, here what we're doing with this is instead of just taking, like with f of x, what we do is we'd take in some value and we'd plug it into like this function, and we'd get out some f of x. What we're going to do is we're going to start with our x. We'll plug it into the g function, and then that output gets put into that f function. And then what we end up with is, so think about what's happening at like this stage right here. We've got this g of x, and that's what's getting put into my f of x. So this is actually going to be an f of g of x. And this right here, this whole process, we could think of that as f of g of x. So we're taking the output of another function and plugging it into our function. That's what we're doing. Now, we use this very specific notation. It's got that circle instead of a dot, so it's easy notation-wise to mix this up with multiplication, but it isn't multiplication. So let's give you an example or two. Let's start off with our example here. I'm going to say that f of x is equal to x squared plus 1. And I'm going to say that g of x is equal to negative 2x. So I'm going to do two things here. I'm going to find our fog, our f of, oops, it's supposed to be a circle, of g of x. And then secondly, I'm going to find our g of f of x and show you that these two things are going to be different. So let's take a look at f of g of x. So think about this. We're taking our f of x, and instead of putting our x in, we're putting in a g of x. So our f of x function was this x squared plus 1. Well, instead of x squared, we're going to put in this expression for a g of x. That's that negative 2x. So that's a g. Now, when I do this, I've got, negative 2x times negative 2x, that's that negative 2x squared, is going to be 4x squared plus 1. This is the composition of f of g of x. Alrighty. So far, so good. Well, let's see what happens when I find g of f of x. Well, same sort of idea. It's just our outer function here, this, when we say g of f of x, that means I'm going to take my g function, and instead of x, I'm going to put in my expression for f of x. So for my g of x, this is negative 2 times whatever this is. Except this time, we're going to be putting in our expression for f of x, which is x squared plus 1. So for my g of f of x, this is negative 2 x squared minus 2. Now I want you to notice these two things are not the same. So there's some very specific things that they will be the same for, but this is not the one. Alrighty, that's all we have time for in this video, so I will catch you in the next one.